Everyone, we're going to solve trig equations with arguments that are not just theta. So they're going to be like 3 theta and things like that. And I highly recommend you watch the introduction video that I did prior to this one. It's in the same playlist. The thing we're going to do is just solve for theta, if this was theta. So if I just solve this as being theta, so sine of theta equals -1, I know that theta equals, for all solutions, would be 3 pi over 2 plus 2k pi. Okay, so we want to set 3 theta to our theta. So we're going to set 3 theta equals 3 pi over 2 plus 2k pi. Now, to solve for theta, we just divide each piece by 3. And then we have our angle. So our angle is 3 pi over 6 plus, let's see, where am I? Okay, plus 2k pi over 3, which is 120. So it's rotating 120. And this actually is pi over 2 plus 2k pi. Now, I know when k is 0, now since we have 2's here, I'm going to change my domain and rewrite this as 0, 4 pi over 2. So I know I can't go higher than 4 pi over 2. So if I let k equal 0, in this case, I just get pi over 2. If I let k, this is should be a 3, sorry. If I let k equal 1, I'm going to get theta equals pi over 2 plus 2 pi over 3. Now, with my common denominator going to be 6, I'm going to write this as theta equals 3 pi over 6 plus 4 pi over 6, which gives me 7 pi over 6. So it's still less than this, because remember, if we're dealing with 6, that would be 12 pi over 6. So it still works. I'm going to write 7 pi over 6. Now, I'm going to let k equal 2. See if I can get another one in here. If I let k equal 2, I get my angle equals pi over 2 plus 4 pi over 3. And that's going to give me, if I have common denominators, 3 pi over 6 plus 8 pi over 6. And so that would give me 11 pi over 6. Which is still less than 12 pi over 6. And you can imagine, or just kind of note, that if I let k equal 3, it's going to be too big, because 11 pi over 6 is really close to this 12 pi over 6. So that's what you do. You just go, because we want to go from 0 to 2 pi, and you're just doing the rotations. All right, the next one we have is 10 theta over 2 equals square root of 3. So the first thing I'm going to solve for is if this were theta. Now if it was tan of theta equals square root of 3, then my angle would be pi over 3. And then I would add, the period for tan is pi, so I would just put k pi, where k is any integer. Now, I want this to equal pi over 3, because we know that's true. So I set that to equal pi over 3 plus your rotation. And again, we want to go from 0 to 2 pi. So I multiply everything by 2 to solve for theta. This will cancel here, and you get 2 pi over 3 plus 2k pi. So if I let k equal 1, then I just get 2 pi over 3, which works because that's less than 2 pi. Now let's let k equal 2, and that would be if k is 0, sorry. And if k equals 1, we get 2 pi over 3 plus, I'm going to go ahead and write this as 6 pi over 3. All right, because that would be if k is 1. And that gives you 8 pi over 3. Now, 8 pi over 3 is bigger than 2 pi. So it doesn't work. We have to discard it, and we can stop. And so my solution, I only have one solution, which is 2 pi over 3. So here's one with cosine. Again, I'm going to just solve as if this was cosine of theta equals negative 1/2. So we know in this case, our angle would be 2 pi over 3. The period for cosine is 2 pi. I'm just writing the general formula, and also 4 pi over 3 plus 2k pi. Now, I want to go from 0 to 2 pi, and I'm going to set 2 theta, because I want my theta to be 2 pi over 3, and 4 pi over 3. So I'm going to set my 2 theta to equal 2 pi over 3, and I'm also going to solve for 2 theta equals 4 pi over 3 plus 2k pi. Now, we're going to divide everything by 2, so you get 2 pi over 6 plus k pi, which actually is pi over 3 plus k pi. And this one's going to be theta equals 4 pi over 6, which would be 2 pi over 3 plus k pi. So I know if k is 0, that knocks this out. So my two solutions would be pi over 3 and 2 pi over 3. And if you know from the introductory video, we know we probably have 4 solutions here. So since I have 3's here, I'm going to go ahead and write this as 0 to 6 pi over 3. So we can't go bigger than that. So let's plug in 1 for k equals 1. And so that we get theta equals pi over 3 plus, if this is 1, that would be 3 pi over 3. And that gives you 4 pi over 3, which works because it's less than 6 pi over 3. And for this one, I'm going to do the same thing, 2 pi over 3 plus 3 pi over 3. And that gives you 5 pi over 3. And you know you can stop there because you know the next one's going to be bigger than 5 pi over 3, which would be bigger than, this can't equal 6 pi over 3. All right. The next one, we have tan of 2 theta equals negative 1. So first I'm going to solve for tan of theta equals negative 1. And tan is negative at 3 pi over 4. So I can say my so theta would be actually 3 pi over 4, and it would also be 7 pi over 4. But since tan, the period is just pi, I can just use this one here, and I'll show you why. So we're going to set 2 theta equals 3 pi over 4 plus k pi, because the period of tan is just pi. That's where this one's going to show up anyway. And then divide everything by 2, so you get 3 pi over 8 plus pi over 2. So we know, oh, don't forget the k. And k is any integer. So basically, if you let k equal 0, we get 3 pi over 8. So this is k equals 0. That one's easy because I'll just knock this out. Now let's see, k equal 1. And you're going to get 3 pi over 8 plus pi over 2, which equals 3 pi over 8 plus 6 pi over 8, right? No. This has to be 8, so it's going to be 4 pi over 8. And that gives us 7 pi over 8, which would be this one if you divided that by 2. Now let's let k equal 2, and we'd get 3 pi over 8 plus 2 pi. Well, this is, it would just be 2 pi over 2, which would give us 3 pi over 8. This cancels. Plus 8 pi over 8. And that gives us, I should have wrote 7 pi over 8. 11 pi over 8. And let's go ahead and let k equal 3. And that's going to give us 3 pi over 8 plus 3 pi over 2. So that equals 3 pi over 8 plus 12 pi over 8, which gives us, whoops, why did I put 18? Okay, so there's going to be 15 pi over 8. So we have 4 solutions here. All right? And we know we can't continue further because for it to be from 0 to 2 pi, and everything's in 8, so I'm going to write that to 0. That would be, we can't go bigger than 6 pi over 8. And we can't, that would end it. Okay, now we have secant. So we're going to do the same thing. We're going to solve for secant of theta equals 3 pi equals, equals -2. So we know that secant, or theta, would be 2 pi over 3. And then what I'm going to do is divide everything by, or it also could be, what, 4 pi over 3. So I'm going to set 3 theta over 2 equal 2 pi over 3 plus 2k pi. The period for secant is 2k pi. And I'm also going to do on this side. And what you're going to do is multiply everything by 2/3. Maybe just take this off here. So multiply everything, and the same thing over here. Multiply everything by 2/3, and you're going to get theta equals 3. Okay, here, where are we? Okay, so theta equals 4 pi over 9 plus 4k pi over 3, or theta equals 8 pi over 9 plus 4k pi over 3. Now, we have to solve between 0 and 2 pi. And what you're going to get is when we get 0, if k is 0, then we're just going to get 4 pi over 9. And we're going to get 8 pi over 9. Now, if k is 1, you can multiply this out. If k is 1, you're going to get 8 pi over 9, or 16 pi over 9. And you can't go any bigger than that. So I'll let you do the math on that. And you're going to get 4 pi over 9, 8 pi over 9, because we shared these two. And then we also have 16 pi over 9. And you could try further. You know you can't go bigger than 18 pi over 9, because that equals 2 pi. Okay, one more. Same thing for this one. I'm going to go a little faster on this one. So we solved for theta, and theta on this for cotan would be 5 pi over 6. And then we're going to set 2 theta over 3 equals 5 pi over 6 plus k pi. Now, you don't have to write all the angles here, because remember, cotan, the period is already just pi. So it captures the other one. Now, solving for theta, you're going to get 5 pi over 4 plus 3k pi over 2, where k is any integer. And then, so on the interval from 0 to 2 pi, we only have one solution, which is 5 pi over 4. Everything else is going to be too big, because remember, you can't go higher than 5 pi over 4. And that's all. Thank you, and have a nice day. The next set we're going to do is list we're going to list 6 solutions. Thank you, and have a nice day. Bye-bye.